Where can we see the live count, the viewer count?
I think it must be somewhere on your
top left.
left, yeah.
Okay. Okay, so shall we start?
Yep. How many are there?
Currently, we have one viewer.
Oh, nice. Must be push.
Yeah. Yeah. So, for anybody who is watching this, hello, welcome. This is part of the Lightning team. Not everybody is here. We also have Ota waiting in the shadows, and this is a stream for us to go over like the recent 1.6 release and the features we have since then. So let me share my screen. So since the 1.6 release, we have already had 3 releases. Well, yes, 3 releases with bug fixes. So 1.6.0 is not the last version anymore. The last version is currently 1.6.3. Oh, wait, we have new people. Let's include them. Hello, Jirka.
Hey, Yuka.
And yeah, so since then we've had 3 releases, so I recommend you guys install the latest and greatest because it's going to be the most stable version. But we can go over the recent features in the 1.6 release. So we have some like the biggest features we've already done streams for, and we have other resources for them. So I'm going to skip over them, but it's good to mention them. One of them is support for Intel's Havana accelerator, which is a new hardware from Intel, and then you can easily enable it just by passing these flags in the trainer. Also for a distributed strategy called PAGWA, which supports efficient communications techniques. And we've also revamped many of the internal components that make PyTorch Lightning so flexible, such as the accelerator strategy and plugins. This work was done by Adrian, who is going to just join right now. Here we have him. Hello, Adrian.
Hi.
Hello. Okay. and we have an entire Medium blog post in the PyTorch Lightning team page describing these changes. Then moving on, so these are things that we haven't gone into, so we can go over them in this session. In terms of the Lightning CLI, we in the previous version we added support for registering components that can be easily enabled through command line with a special notation that's much shorter. However, this required that the users manually add the decorators to their components, etc. And now we just have a single Boolean flag that will enable this for all of your components. So you set this in your Lightning CLI, and then any Lightning module that you have defined in your code base that is currently imported will be available for use in the Lightning CLI. So here's an example where, like, for example, this is the shorthand notation for the optimizer or the LR scheduler. And in the case of the scheduler, we added support for reduce alert on Plato scheduler, which is one of the most popular ones. Linked to this is also support for customizing the configure optimizers, because the CLI overrides the configure optimizers hook from the Lightning module. And we've also allowed loggers to be passed in this shorter notation. So, for example, just with this command, you can use the widths and biases logger, which is very popular as well. Adrian, do you want to describe this feature?
Oh, yes. Yeah, I remember this. So, yeah, this is useful for Slurm users. So Slurm users when they submit jobs to the cluster, they usually use like a submission script, and the cluster usually terminates the script after some time. So there's like, on a managed cluster, there's usually some fixed amount of time that you can use the resources, and then it's going to basically kill your job. But if your training needs to run longer, then that's annoying. And you can, by default, Lightning re-queues, resubmits the job. So basically, it will go back into the queue of the cluster and re-queue. But sometimes you want to control that and not have that. So here in the trainer now, using the plugin, you have the control to toggle this on and off. So yeah, that's just for Slurm users, and it's very convenient, and you don't have to handle this through signal handlers and add a lot of boilerplate to do that. This is handled in Lightning. So yeah, this is really small change, but hopefully useful to the Slurm community.
Yeah, it's very appreciated. Some of our Slurm users were frustrated because they wanted to control this and they couldn't before. And if you guys are familiar with the Python signal registration, it's easy to register, but not so much to unregister. And that had many problems with them having to like snoop into the internals of the code base. So now it's very simple, which is this flag. Then moving on, fault tolerance is a feature that PyTorch Lightning allows, but it's still experimental. So we are constantly trying to improve it to bring it to the most, like the widest audience we can. And in that regard, we have added support for tracking optimization progress for manual optimization. So remember, GAN users, they need to control the optimization procedure inside the Lightning module. And this used a different loop entirely. A loop, when I say a loop, I mean one of our internal loop components. And then we support progress tracking, so knowing how many optimizer steps have happened, etc., for those kinds of users. Additionally, we added support for handling the unexit signal with a different signal type, which is very useful for cloud training, and also support for chaining consecutive feed calls, which is something that people expect to work seamlessly, and it didn't before. It like the state wasn't correct after the second call, and now it should work perfectly with the only requirement that you change the number of max epochs if you are in a epoch-based training setting. Additionally, in terms of like user experience for loop customization, which is was a feature in the previous release, we've added this simple method to replace one for another and then reduce the surface of bugs and problems by the users. We've also removed some requirements that data loaders had in PyTorch Lightning when you try to train under a distributed setting, because we need to do some magic in the back and replace some components for another. Now we added more magic into the mix, and now we do it for you as much as possible, especially if you insert these data loaders inside a hook. And Ota, who I don't know if he's here, he's new to the team, and he's currently doing more and more improvements to improve the usability around this piece of the code. So be on the lookout for that in the next release. Additionally, one internal change that I find interesting, maybe you don't, but let's mention it, is that before PyTorch Lightning had to prefetch one batch to make sure that there was still like whether to know whether we needed to run validation and things like that, because sometimes you don't have the length of your dataset, and now that's not a hard requirement in all cases, which improves the integrations with libraries that also want to control the prefetching for efficiency reasons, like FFCB, etc. Rohit, do you want to cover this group?
Yeah, sure. So the main motivation to add this one was TIM package. So TIM is a very popular image model package that has all kinds of vision models available. Plus, it has its own schedulers, but the API is sort of different. It's not exactly like it doesn't take PyTorch native LR scheduler as the base class. It has its own schedulers. So we just wanted to make sure that this is supported too. I mean, all popular external packages should be supported, and this hook allows you to create your own custom schedulers and use them easily.
Cool. And Adrian, do you want to mention the stateful API?
The stateful API.
Mm-hmm.
Yeah. So this is more like a standardization. So um, basically, we are splitting the concept of like when you actually retrieve the state from a component versus when you observe the state from the entire checkpoint that it's loaded. So, for example, onload checkpoint uh, was inconsistent in Lightning module versus data module versus other component, where sometimes it returned the state of that component, sometimes you just uh, got the checkpoint as input. And now we standardize this so that basically there is this new hook called state dict, inspired by the regular NN module and state dict. And this one always returns the state of the current component. So for example, the callback, the Lightning data module, the Lightning module. And then the load state dict does exactly the opposite. It loads the state from the checkpoint for that component. And the other hooks that you previously used on save checkpoint and on load checkpoint, they still exist, but they are always used to observe the entire checkpoint that is loaded. So there you will always get the entire checkpoint. And if you need to modify it, you can, but it's not meant anymore to modify the state of the current component. So it's you can see that's a standardization. It's nice that now it behaves the same way in all the components, and yeah, so nice improvement.
Cool. Also, for anybody who's watching, if you guys have questions about some of these features, or you wonder why we did something one way instead of another, something like that, just be sure to post it in chat and we will discuss it. In addition to the previous, we also added some new properties that you might find useful in your trainer sessions. Rohit?
Yeah, so this was again one of the requested features, like the most requested feature. So estimated stepping batches helps you retrieve the total optimization steps that are going to happen in your training. So it's like a standard property that can help you even if you're doing, let's say, training based on max steps, or if you are just using normal journal way of training using max epochs. And even if you are using DDP, then ideally DDP enhances, like expands your effective batch size and thus reduces number of optimization steps. So this property handles everything. So all you need is just to change your flags, whatever is your requirement, and use this one to get the total optimization that is going to happen.
Thank you. A person, okay. Yes. Mr. Pull Request asks, should it be cell.x equals the key x inside checkpoint? I believe that's the case, right, Adrian? Right here.
So here in this simple example, self.x equals x. Yeah, it's a little bit pseudocode here. Well, you can theoretically just do anything you want, but yeah, probably what you would normally do is index into the checkpoint that you get. Yes, that's true. Good.
We will
Good
do
point.
that.
Thanks.
So moving on, we have also added some properties that are a little bit more usable, which are num devices and devices IDs, and these are agnostic to the actual hardware you are using. In the past, you will have to do something like if your trainer script could be run in multiple settings, then you have to have some logic like this, where you are taking the max of all of them. And this means that your code is exposed to all these properties and you have to take all these, like write all these logic yourself. Now you can choose to access the attributes directly. Then moving on, in terms of more and newer experimental features, there's manual fault tolerance. Fault tolerance is a complex topic, and it has different elements to it, but one of them is, and the hardest one, is saving the state of your data loaders, right? So in PyTorch Lightning, we do quite a few things to try to save it in a fault tolerance way for the base cases, but depending on your data loader setup, it might not be possible. So manual fault tolerance allows you to write some code so that you can add the fault tolerance logic for your specific setup and have training still work. So you can read more about that in the docs link inside of here, and we also have a video with Thomas discussing this feature with an engineer from Microsoft, if I'm not mistaken. Then we've also added an internal component for layer synchronization. Arian, do you want to describe it?
Oh yes, this is more like for I would say, very advanced users who need to use a custom way to sync batch norm. Maybe these users are also using like strategy API to customize their strategy or accelerator, and so far we've just internally basically hard coded the batch norm from Torch, the native one. And now we just made it a plugin. So if it's a plugin, it means you can customize it, you can replace it. Yeah, and that's basically another plugin that we added, and yeah.
Nice. Then additionally, we've added support for registering your own accelerator, which we don't really expect people to do, right? Because accelerators usually are added support inside the repository themselves, but it is something that will be useful in the future. And that's basically all the features, the main features we've had for the release. There's a super long list here at the end of the changes. Like if you open these these boxes, then it will show everything. And this also describes some of the backwards incompatible changes that we've done or had to do for this release. Like we have a four version window for PyTorch support. So with this release, we dropped support for 1.7. Somebody's asking, how is this plugin different from a callback? I guess they are asking about layer sync.
Yes, I can answer that. So in general, a plugin is different from a callback in mainly one way. So a callback is very general. So a callback just has a fixed number of hooks that get called anywhere in the trainer. So the trainer decides when these hooks get called, and they are always the same. And you can have as many callbacks as you want, and all the code that lives in the callback is basically user-specific code. You implement the callback, and you provide the code that runs inside of these hooks. A plugin is different because a plugin it follows, each plugin has like a very, very specific API that is specific to this plugin. And you don't really implement plugins, you more like select them. So you pass them in, and this changes the behavior of the trainer. But it's more specific. And then there are contracts between the plugins and individual components that need to be satisfied. Something that is not the case with callbacks. Callbacks, they don't have a contract with other components. So basically, you use plugins to customize very specific parts of accelerators, strategies, and so on in Lightning. And callbacks, you use them to customize additional events that happen during the training process. Yeah, so Or another way to put it is you use callbacks to inject code that runs in addition to your trainer, and plugins, you use them to change the behavior of components in Lightning. Yes.
Then continuing with the backwards incompatible changes, we drop support for Python 3.6. You shouldn't be using it anymore if you are. We did a rewrite for an internal component called the accelerator connector, which contains all the logic for choosing your accelerator, your strategy, the different plugins, handling the flags. Like, it's a lot. So we had to completely rewrite it. And then for the sake of fault tolerance, we had to do some tricky changes to the internal progress tracking. One of them is redefining the current epoch boundary, so exactly where the current epoch is increased, because in PyTorch Lightning, an epoch contains many hooks, and where you increase this value relative to the hooks that have run is important depending on the code of inside those hooks. Now, what I mean is, for example, the easy example is checkpointing. You might want to increase the current epoch before or after checkpointing. In this case, before this release, we increase the current epoch before. Now we do it after. And similarly, we had to do a decision like that for global step, where before it will be increased after validation, and now it is increased before. And this has impact to the save checkpoints, etc., and the global step value, etc. So it's a bit involved, but if you have any questions, you can drop them here or ping me in Slack. And some much smaller changes. We no longer reduce outputs automatically for training step when the data parallel strategy is used. This shouldn't be an important change for most people. And a tricky one is that we no longer fall back to CPU when no devices are set, because like before, people found useful that if you will pass a number of GPUs, uh, like something like 0, and then that will run on CPU. But we no longer support that because we have a new API called devices, so the flag devices, where you can specify auto, etc., and that will choose the best setting for your train. So all in all, those are the main changes. We had a huge list of contributors. I think 99 contributors total. So if you want to be in this list for next release, you can check out our issues list in the GitHub repository to find items that maybe are interesting to you or are easy to get started contributing to an open source repository. And yeah, we will see you in the issues and PRs. Anything else you guys want to mention? Okay.
Yeah, no, I just wanted to say that I'm really happy about the release, especially like the accelerator and strategy changes, the decisions we made. I think it's really nice for the future. And actually, yeah, I'm really happy about the strategy API, even though, so this is something that is most people, most PyTorch Lightning users probably will not notice, because like they've always just used the trainer flags to set them and train, and whatever works for them, it works. But like under the hood, we've always made these refactors and changes, and now that the strategy API and the accelerators are stable, it really makes it easy for us to add quickly new features like Bagua, like we did in 1.7. And even now, after 1.7, in the next release, we will have like a new collaborative strategy and native sharded. And what this enables us to do is just deliver these features faster without affecting other parts of the code base, because this is a very isolated API, and a lot of work has been done under the hood, and to make this happen. So yeah, this is really exciting for me.
Yeah. So we have 2 questions. Let's see them. Mr. or Mrs. Pull Request asks, we want some tutorial focusing on DDP training. For example, things that should be taken care of in terms of login, evaluation, loss accumulation, etc. Currently we are doing a complete revamp of the documentation where we will be having different levels so that for somebody who's beginner, they can get started in an easy way. And then for people who are more interested in things like loss accumulation or things like that, that will be sequenced and included in a guide uh, that that is comprehensible for your experience level. But doing DDP training in PyTorch Lightning is generally as easy as just setting the strategy equals DDP flag in your trainer. Trainer.log will work out of the box. The only question is whether you want to synchronize the values across your multiple devices, etc. And the loss is accumulated automatically internally.
Yeah, and I guess here also, like probably this tutorial or this guide pull request is asking is more like, what are the best practices that are already in Lightning that we already take care of, and what are the best practices that are left to the user? It's sometimes not easy to know, right? What does Lightning do? What do I need to do? Yeah, so one thing that often comes up is like logging, like pull request said, and Lightning already does a lot of stuff there, and it allows you to sync the loss, but sometimes that's not enough, and sometimes we need to say, oh, actually the best practice is to use torch metrics, because then you define your metric and you make sure by using torch metrics that the end result of the metric is actually correct. So these kind of details can matter, and it's nice to have a tutorial or someone telling you that you should do it this way and not the other way. Yeah, so maybe that comes in the future. Yeah, I agree that this is useful.
And the other question is from one pot dish. Can we get the average training loss from the trainer? So using training step, I can get the loss after each step, but I want to get the average loss after it. So for this, you can do multiple things. One of the solutions will be like, and the more custom one will be what Adrian just said, of like having your own metric that maybe is an average metric, and then you update it, and you can access that at any time during training and call compute on it. So please check out the Torch metrics repository and all the metrics they provide. Another much simpler thing you can do is to have self.log inside your training step, and then self.log can take an argument called on epoch. You set that to true, and then at any point after that in training, you can access self.trainer.callback metrics, and that will contain this value, the average loss value for the, and that's just a Python dictionary.
Yeah, and here is something that I always like, something that I never really fully understood is like, why are people interested in like computing the average loss over an epoch? Because what does it even mean, right? Because if you track the loss and put it in a list and then in the end compute the average, like the loss at each step is like produced by a network that changes the weights over time, right? In every training step, you change the weights. So it's like a loss that maybe decreases or goes up or whatever, and you compute the average over that. What's the meaning of that? I guess in the end, you're just interested like whether that goes down over time or not. But yeah, it's interesting that people compute the average loss this way. Most of the time, probably you are interested in the validation loss. But then if you compare that to the average loss on the training set, like you don't really know. It's not really a good way to know if you're overfitting. So the correct way would be to run again over the training set and then compute the average with like the weights fixed, right? So just a small, like, sorry about this weird discussion, but like I always like didn't understand that. So yeah.
Yeah, I agree. And one interesting fact about PyTorch Lightning internals is that when you self.log inside a hook, we have these two arguments that I mentioned about onStep and onEpoch, right? And they are, by default, they are set to none, and we choose them what are the actual value for the user, depending on the hook. And particularly, the training step hook has logs only on step and not on epoch for exactly this reason that Adrian mentioned, right? Because it's generally not useful to compute the mean over the loss. Over the loss during training.
Yeah, but anyway, if people want to do that they can, and it's super easy. So yeah, nice.
Another question is CLI stable now? Seems like JSON parts is still changing. So the CLI is tagged as an experimental or beta component inside the documentation, but I can assure you that the main interactions with the CLI are not going to change, right? We are still going to have like subcommands, and the arguments are going to be passed the way they are, and like the hook add arguments to parser hook inside the CLI. That's not going to change most likely. Now, is JSON parts still changing? Absolutely. Is that a good thing? Absolutely as well, right? Because the more that the CLI is completely enabled by JSON parts. So we are very thankful of the JSON parts author, who is very involved into the development of the CLI, and the fact that it keeps changing is useful to us because it allows us to build newer and nicer features on top of it. We recently had an issue where there was a breaking change, and that impacted the users, but it should be fixed by upgrading to the latest JSON parts version. Cool. So how are we doing on time, Rohit?
Yeah, it's 30 minutes. We are on time.
Okay.
I mean, we can wait if we have more questions to answer.
Any more questions, guys?
Looks like we don't. But I mean, yeah, if you guys have any questions, hop onto Slack and ask. We are happy to answer you.
Yeah, and unfortunately, not the entire team is here, but just know that we are a team of 10 people in the PyTorch Lightning team, and we are distributed across the globe basically. So we are almost always, and like looking at the repository for new issues, new PRs, and also discussions. So yeah, see you guys in the repository.
Yeah, see you guys in the next release.
Exactly. Bye, everybody.
Bye, everyone. Have a nice
Bye.
week.